Hi, welcome to Venkatvarma Chemistry YouTube channel. I am Venkat Varma, your host and chemistry enthusiast. We are here to make JEE NEET chemistry preparation easier, more effective. Join us for the short, easy to understand videos that cover tips and tricks to ace your exams. Today we can discuss the complete revision of alcohol in one shot. Complete alcohol in one shot. Let's start our session. Alcohols. Let's move on. Alcohols. See the general methods of preparation of alcohols. See the general methods of preparation of alcohols. The first one is hydrolysis of alkyl halate. Hydrolysis of alkyl halate. So what type of reagent used for the hydrolysis of alkyl halate? The reagent is aqueous sodium hydroxide or aqueous potassium hydroxide or moist silver oxide Ag2O. It means what? Silver hydroxide. This reagent used for the hydrolysis of alkyl halate. See, alkyl halates, its general formula is RX. Alkyl halate, its general formula is RX with, for example, sodium hydroxide. Sodium hydroxide in aqueous medium means water. It gives what? Alcohol or OH plus NaX. See, very simple, easy to write. So NaX we can remove to form a alcohols. Yes, I am taking example C2H5Br with KOH, potassium hydroxide, aqueous medium. It gives C2H5OH plus KBr. Removal of KBr to give alcohol. Yes. See, the primary alkyl halate to give alcohols. Secondary alkyl halate, it gives alcohols or alkenes. Tertiary alkyl halides, it gives alkenes. So I'm taking example. See, primary alkyl halate. See, primary alkyl halate, it gives what? Alcohols. See, secondary alkyl halate. Remember, secondary alkyl halate, it gives alcohols plus alkene. Yes. Now, tertiary alkyl halate. Tertiary alkyl halate, it gives alkenes. It gives alkenes. Yes. See, it is a dehydrohalogenation. Dehydrohalogenation. See, I am taking example. See, tertiary butyl bromide. Tertiary butyl bromide in presence of aqueous KOH. Aqueous KOH. It gives CH3 double bond CH2 plus KBr plus H2O. It is a dehydrohalogenation. Dehydrohalogenation. This is a method for hydrolysis of alkyl halate. Let's move on. The next method is from alkenes. From alkenes. From alkenes by using oxidation method. By using oxidation method. See, alkenes means, see, carbon with a single bond. Yes or no? So generally alkenes, primary and secondary alkyl halides do not undergo oxidation. So This alkene has one hydrogen in presence of strong oxidizing agent potassium permanganate. It gives alcohols. It gives alcohol. Yes, I am writing example. See, in presence of KMnO4 oxidation, it gives tertiary butanol. Yes, it gives tertiary butanol. Yes, let's move on. The next method is from alkenes. From alkenes, the methods are hydration method. Yes, oxymercuration and demercuration, and HBO, hydro bromination. Sorry, hydroboration oxidation. The first one is hydration. See, hydration. What is the reagent? See, carbon-carbon double bond. It is a alkene. Yes, in presence of water. Water means H plus OH minus. Yes or no? See, if the pi bond is attracted HOH, yes or no? The pi bond shifted here, partial positive charge, partial negative charge. I am taking one more example, CH3, CH double bond CH2. It is a propene in presence of, say, H plus OH minus. What is the product? C. Partial positive charge, partial negative charge. It gives CH3, CH, OH, CH3. The name of method, it is a direct method, hydration. Yes. So it is the main point is formation of carbocation. Yes, formation of carbocation. Formation of carbocation is the rate determining step. Formation of carbocation is a rate determining step. Yes. Now, rearrangement is possible. Yes, rearrangement is possible. Rearrangement is possible. Yes. Next, the rearrangement possible go through major product. Yes or no? Next, it follows Markovnikov's addition. It follows Markovnikov addition. Markovnikov addition of water. Markovnikov addition of water. Yes. Let's move on. It is a direct method. Direct method. What is the indirect method? See, go for the indirect process. For indirect process, what is used? Sulfuric acid. H2SO4. See, alkene CH2 double bond CH2 plus HOSO2 OH means H2SO4. It gives C H plus HSO4 minus. Yes. C CH3 CH2. So OSO2H. OSO2H. Yes. Again it is boil. Again it boils in presence of H2O. It gives CH3 CH2OH plus CH3 CH2OH. See, in case we are taking unsymmetrical alkene, what is the product? Unsymmetrical alkene. See, unsymmetrical alkene. See, symmetrical alkene is taken. Unsymmetrical alkene is taken. See, I am taking CH3, CH double bond CH2. Yes. in presence of HO, SO2, H plus, HSO4 minus. Yes, the pi bond is shifted. So what is the product? Say it follows Markovnikov's rule. See CH3, CH, CH3, O, SO2, OH. Yes or no? Sorry, SO2H. Yes. Again, presence of water, boil. It gives what? CH3, CH, OH, CH3. Yes or no? It is what? Isopropyl hydrogen sulfate. It is a isopropyl hydrogen sulfate. This is the product. So it follows what rule? Markovnikov's rule. Markovnikov's rule. Let's take one more example. One more example. See, I am taking one question. If I am taking double bond CH2 CH3. This is the alkene system. In presence of H plus, what happened in presence of H plus? So it forms carbocation. Yes, it forms carbocation. CH2. Sorry. I will look. I will look. To form a carbocation in presence of H2O. In presence of H2O, what happened? To form a C3 CH3 OH. Yes, to form a alcohol. To form alcohol. Yes. Now, one more example. See, if I am taking CH3, CH3, CH double bond CH2. What is the name of compound? See, methyl to butene in presence of H2O. In presence of H2O means H plus. What happened? See, CH3, CH3, C, CH3 to form a carbocation. Yes or no? It is what type of carbocation? It is a secondary carbocation. It rearrange. The methyl shift is occur. It forms CH3 plus CH, CH3, CH3. See, now look for reaction. See, to form a tertiary carbocation. So, carbon having say 3 methyl groups, CH double bond CH2, hydration. It forms pi 1 shifted to CH2, carbon getting positive charge. It is a secondary carbocation. So it is a methyl shift to form a tertiary carbocation with the OH minus. It gives CH3, CH3, OH and CH, CH3, CH3. This is a hydration product to form a alcohol. Yes, let's move on. Next method, oxymercuration and demercuration. Oxymercuration and demercuration. So in presence of alkene, see, I'm writing alkene R CH double bond CH2 in presence of mercuric acetate HgO AC2 mercuric acetate in presence of H2O and THF tetrahydrofuran, yes, and in presence of sodium borohydrate in BH4 and OH minus, it gives alcohol or CHOH CH3. It can form alcohols. Yes. To follows Markovnikov rule, no rearrangement. In oxymercuration, demercuration, there is no rearrangement. I am writing mechanism for this reaction. See, have a look for mechanism. See. See, CH3. See, CH double bond CH2. It is a propene. Yes, sir. In presence of mercuric acetate. So HG OAC OAC mercuric acetate. See, this pi bond is attracted to mercury. See, acetate is leaving group. So the mercuric attacks over on the carbon positive charge. In the first step, oxymercuration. In the first step, oxymercuration. See, the electrophile of mercury and mercuric acetate at the double bond. The mercuric acetate at the double bond to form a cyclic mercurium ion. To form a cyclic mercurium ion is CH3, yes, and CH and CH2, okay, and HG OAC, yes, and acetate. It is a cyclic mercurium ion. See, cyclic mercurium ion. Yes, the cyclic mercurium ion. So in the second step, water is attacks, H2O is the most substituted carbon atom. Most substituted carbon atom, H2O is attacks to form a CH3, yes, CH, CH2, HGOAC. Here attacks water, CH2. H2O is attacks. See. Again, it is a what process? It is a oxymercuration. See, it is a oxymercuration process. Yes. Again, acetate, it a proton, yes, to forming CH3. See, I am writing product CH3, CHOH, C, CH2, HGOAC. Yes. Again, it is treated with sodium borohydrate. Sodium borohydrate. In presence of sodium borohydrate, it is demercuration. It is a demercuration. Sodium borohydrate in presence of OH minus. It gives breaking of carbon and hydrogen bond and making of carbon with hydrogen bond. CH3, CHOH, CH2, CH3 plus HGACO. This is the product. This is the mechanism of oxy. The first step is a oxymercuration. Second is a demercuration. That's why oxymercuration and demercuration. Oxymercuration and demercuration. So what is the product? It is a Markovnikov's addition. See, it is a Markovnikov addition of water. Markovnikov addition of water. Yes. So without rearrangement, the product is formed. Have a look for C. Have a look for question. See, for example, this is the previous question. See, is alkene system in presence of oxymercuration. The product they are asking is mercuric acetate in presence of sodium borohydrate NaBH4. What is a product? See, the first method is a oxymercuration. See, in oxymercuration, what is a product? See, HgOAc, and here attacks water. Yes, in presence of sodium borohydrate. Sodium borohydrate. So breaking of carbon with mercuric bond C2 forming hydrogen. Yes, this is our required product. This is the required product. I will look for one more question. I will look for one more question. See, cyclohexane with CH double bond CH2 in presence of mercuric acetate. Yes, mercuric acetate. What is the product? See, cyclohexane with the C. Here attacks what? HgOAc. Yes, with the CH2 HgOAc. Yes, in presence of H plus. To follow Markovnikov's rule to form a product. H and CH3. It is a secondary alcohol. Secondary alcohol is formed. Yes, I will look for next method. See, hydroboration oxidation, HBO, hydroboration oxidation. Yes, hydroboration oxidation. I am writing very important point. It is anti-Markovnikov's orientation. Markovnikov's orientation. Yes, carbocation is not intermediate. Carbocation is not intermediate. Carbocation is not intermediate. Yes, no rearrangement. No rearrangement in hydroboration oxidation. Yes, first I am writing reaction. See, carbon double bonded with carbon. Yes, in presence of diborane B2H6. Yes or no? B2H6. B2H6 is an electron deficient compound. B2H6 is an electron deficient compound. See, I am writing BH2H. In presence of diborane, it attacks C. H BH2. Yes, in presence of hydrogen peroxide H2O2 and OH minus, it gives product C. OH, H and H, it gives alcohol. So it comes where diborane B2H6. It is a electron deficient molecule. Yes, diborane. It react with alcohol. It react with the alkene to form a alcohol. Yes, I am writing complete mechanism. See, or H double bond CH2 in presence of H BH2. Yes, see, or CH2 means attacks the pi bond H and BH2. Yes, in presence of again 1 mole of alkene CH double bond CH2, it forms, see, it forms or CH, yes, CH2 B BH. Yes, again it is treated with 1 mole alkene system, it forms or CH2 3 and boron in presence of H2O2, it gives alcohol, see, or CH2OH. Yes, it is a alcohol. It is a trialkyl borane. It is a trialkyl borane. It is a trialkyl borane. Yes, I am taking one more example. See, what is the mechanism? The mechanism is the addition of boron with alkene system followed by OH minus and H2O2 to give the alcohol is a hydroboration oxidation. The addition of boron to alkene followed by reaction OH minus and H2O2 to give alcohol is a hydroboration oxidation method. Hydroboration oxidation method. See, let's take example. See, for example, CH3 CH double bond CH2. Yes, in presence of H3 and H2O2 and OH minus. What is the product? Very simple, writing CH3 CH2 CH2 OH. Yes, it is 3 moles. It is a regiochemistry of hydroboration. Hydroboration of regiochemistry is a anti-Marconic of addition of water. Addition of water. Anti-Marconic of addition of water. What is the stereochemistry? What is the stereochemistry of hydroboration is syn addition. It is a syn addition. Syn means same side addition with H plus and OH minus on the alkene system. Yes. Next, let's take one more example. See, what is the question? See, cyclohexane with the CH double bond CH2 is in presence of B2H6. It forms, see, CH2 3 with boron in presence of H2O2 and OH minus. It gives what? CH2OH. That is a product. It is what alcohol? It gives primary alcohol. Yes. If I am taking same example for oxymercuration and demercuration, what is the product? HGOAC2 in presence of sodium borohydrate. What is the product? Very simple. See, it gives CH3OH. It gives secondary alcohol. If the same reaction with hydration, what is the product? Same reaction with hydration. Hydration means H3O plus. Yes or no? What happened? Pi bond is shifted, positive charge. So here I am writing reaction C. CH positive charge and CH3. So here hydrogen is there. It is shifted to form stable carbocation. Stable carbocation in presence of OH minus. In presence of OH minus, it gives CH2, CH3. Here form OH. Here form OH. This is the required product. Yes. This is a carbocation rearrangement. Carbocation rearrangement. Let's move on. I'm writing one question. System in presence of hydration. In presence of hydration, what is the product? It forms C. This is the product. Yes. In presence of diborane, same reaction with the diborane. So B2H6. In presence of H2O2, what is the product? Here there is no rearrangement. Yes or no? Yes. Same reaction with the oxymercuration and demercuration. Oxymercuration and demercuration. What is the product? What is the product? See, it forms. This is the product. Yes. I will look for question C. This is the previous question. See, the question is CH3, C double bond, CH, CH2, CH3 and CH, CH3, 2 in presence of diborane B2H6 and presence of H2O2 and OH minus. What is gives A, and it is treated with dilute H2SO4 heated, it gives B. It gives B. See, first is a diborane. Yes. After that dehydrogenation. See, I am writing in presence of diborane. In presence of diborane, what happened? See, I am writing CH3. See, H, CH2, CH3. Here what happened? Here BH2 is attacked. Here H is attacked. Pi bond is attacked. After that we can add again 1 mole of alkene system. Yes. CH2, CH3, CH, CH3, 2. Yes, I am writing. Direct 2 moles. CH3, CH, CH, CH2, CH3. Here CH, CH3, 2 and is a trialkene system. Yes. Again it is treated with what? In presence of H2O2. Yes. It forms CH3, CH, OH, sorry, here H, here CH, OH and CH2, CH2, CH3. And CH, CH3, 2. 1, 2, 3, 4, 5. See, 1, 2, 3, 4, 5, 6, sorry. See, it gives alcohol. It is a product. Now coming to in presence of dilute H2SO4. To give what? Dehydration occurs. CH3, C double bond, CH3 2 and CH2, CH2, CH3. It is a major product. It is a major product. See, have a look for one more. CH3, 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 CH double bond CH2. In presence of B2H6 diborane, in presence of H2O2 OH minus, what is a product? Hydroboration oxidation. It gives what? Alcohols is formed. CH3, CH2, CH3, CH2, CH2, OH. This is our product. Yes. Have a look for next reaction. Have a look for production of carbonyl compound. Carbonyl compound means aldehydes and ketones. See, aldehydes and ketones is converted to alcohol. What is the reagent used? So the reagent is generally hydrogen in nickel, okay, or platinum or palladium, or sodium by ethanol or sodium in ethanol, or zinc and HCl, yes or no, or lithium aluminum hydrate, or sodium borohydrate. These reagents are used for reduction. So these are reducing agents, yes or no. Aldehydes and ketones are converted to alcohol. See, Bolt blank reduction. What is Bolt blank reduction? See, aldehyde CrCHO in presence of sodium in ethanol. Sodium in ethanol, it gives alcohol. What alcohol it gives? It gives primary alcohol. It gives aldehydes in presence of sodium in ethanol. It gives primary alcohol. Again, I am taking ketone. See, I am taking ketone. Ketone reduction with the sodium ethanol. Sodium in ethanol. It gives secondary alcohol. It gives secondary alcohol. Second year. Bolt blank reduction means aldehydes ketone in presence of sodium and ethanol. It gives primary alcohol with aldehyde, ketone with secondary alcohol. See, I am taking what is the reagent? Sodium borohydride also. Okay, or nickel or platinum. Yes. See, I am taking example. For example, this is our question. I am giving the question. See. H2 double bond. I am taking hydration. What happened? See, it is related to hydration question. Okay. See, it forms carbocation. Yes, carbocation. See, in presence of H2, it gives OH. Yes, and CH3OH. Again, it is treated with diborane B2H6. What is the product? Diborane. Hydroboration oxidation. What is the product? Very simple. It gives alcohol. Alcohols. heteroboration oxidation. Yes. See, have a look for reduction with reduction with lithium aluminum hydride. See, reduction with aluminum hydride. What happened in presence of lithium aluminum hydride? It is a better reducing agent. It is a better reducing agent or strong reducing agent. See, carbonyl compounds are converted to alcohol. See, it is does not reduce. See, it is does not reduce carbon-carbon double bond. Carbon-carbon double bond not reduced. See, I am writing CH3, CH double bond CH and CHO in presence of lithium aluminum hydride. What is the product? In presence of lithium aluminum hydride, the aldehydes are converted to alcohol. Very simple. CH3, CH double bond CH, CH2. The double bond are not reduced. Not reduced. It is what? It is a protonaldehyde. It is a protonaldehyde. See, have a look for one question. See, I am taking cyclohexanone in presence of lithium aluminum hydride. What is the product? In presence of D plus. What is the product? See, this is the product. Yes. See, in special case, lithium aluminum hydride, see, reduce carbon-carbon double bond also. So, conjugated with phenyl system. See, if conjugated with phenyl system, carbon-carbon double bond also reduce. I am taking example. See, PH, CH, double bond CH with CHO. Yes, it is a alpha beta unsaturated carbonyl compound. Alpha beta. See, in presence of lithium aluminum hydride, it is a special case. It is a special case. See, it forms what? PH, CH2, 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 OH. CH2, OH. Yes. See, one more important. See, catalytic hydrogenation. Catalytic hydrogenation reduces carbon-carbon double bond as well as carbonyl group. Carbonyl group. Yes. Next, let's move on. If I am taking one example, it is a epoxide. Yes, CH2, CH2O. It is a epoxide. Epoxide are reduced in presence of lithium aluminum hydride. It gives alcohols. It gives alcohols. Yes, CH3, CH2, OH. It is a epoxide. Epoxides reduces into alcohol. Yes. Next, MPV reduction. What is MPV reduction? Mervin-Pondrep-Verley reduction. Mervin-Pondrep-Verley reduction. Yes, what is what? What is it? Aluminum isopropoxide is known as Mervin-Pondrep-Verley reduction. What is the reagent? aluminum isopropoxide. See, what is a reagent? See, aluminum isopropoxide. What happened in this reduction? See, ketone. So ketone in presence of alcohol. In presence of alcohol. Ketone in presence of alcohol. What is the reagent? Reagent is aluminum isopropoxide. Aluminum isopropoxide. This is a product. See. This is the product. The reduction. It gives what? See, ketone alcohol. It gives alcohol. Alcohol is converted to ketone. Yes, is ketone. It is alcohol. MPV reduction. So the reverse reaction is oxidation. Opener oxidation. What oxidation? Opener oxidation. Oxidation reaction. This reduction, it is oxidation. I am taking one question about this. See, ketone, yes, it is alcohol in presence of aluminum isopropoxide. Isopropoxide is a product. Ketone is converted to alcohol. Yes, and alcohol is converted to ketone. It is ketone converted to alcohol. Alcohol converted to ketone. It is a MPV reduction. MPV reduction. So the reverse reaction is opener oxidation. Opener oxidation. Have a look for next reaction. Reduction of carboxylic acid. Sorry, reduction of carboxylic acid. See, reduction carboxylic acid formula or COOH. Yes, in presence of lithium aluminum hydride reduction, it gives what? It gives alcohol or CH2OH. Yes, again acyl chloride or C double bond O or C double bond OCl, acyl chloride in presence of lithium aluminum hydride. It gives what? It gives alcohol or CH2OH. Have a look for ester or C double bond O or presence of lithium aluminum hydride reduction. It gives what? It gives alcohol or CH2OH and ROH. Again anhydride or C double bond O, C double bond O or in presence of lithium aluminum hydride. It gives alcohol RCH2OH plus RCH2OH. It gives alcohol. Next, important, amide or C double bond O NH2 in presence of lithium aluminum hydride. It gives amine or CH2 amine. Amide to amine. Yes. Next, let's move on. Esters also reduce to alcohol. The reaction is Boult-Blanc reduction. Ester CH3 C double bond O OCH3 in presence of sodium by ethanol. It gives alcohol CH3 CH2OH plus CH3OH. It is a ester. Also reduced in sodium and ethanol. The reaction is Boult blank reduction. Boult blank reduction. Yes. Next reaction from esters. Alkaline hydrolysis. See, esters formula RC double bond O or S ester in presence of sodium hydrate Na plus OH minus. Yes, it form RC double bond O minus Na plus ROH. Again CH3 C double bond O C2H5 ethyl acetate in presence of sodium hydroxide. It forms CH3 C double bond O Na plus C2H5OH. So the reaction order equal to 2. It is the second order reaction. Alkaline hydrolysis. Remember, alkaline hydrolysis, its order equal to 2. Alkaline hydrolysis is a saponification. It is a saponification. Yes. Have a look for hydrolysis. See, acidic hydrolysis. See, ester RC double bond OR in presence of acidic H plus. Yes, and H2O excess. It gives RC double bond OH plus ROH. Yes, I am taking example CH3 C double bond O C2H5. Yes, next, in presence of H plus hydrolysis, what is the product? CH3 C double bond OH plus C2H5OH. Yes, have a look for next reaction from primary amines. Primary amine means RNH2 in presence of NaNO2 plus HCl. NaNO2 HCl or HNO2. What form? It forms alcohol ROH plus N2. So I am writing CH3 CH2 NH2 in presence of NaNO2 plus HCl. It forms what? CH3 CH2 N2 plus Cl minus diazonium salt. Yes, it is unstable. It forms what? CH3 CH2 plus. Yes, and it gives N2 plus Cl minus. From Grignard reagent. What is Grignard reagent? Alkyl magnesium halide is a Grignard reagent. See, primary alcohol. See, primary alcohol. Alkyl magnesium halide. See, it gives ROMGX in presence of acidic hydrogen. ROMGX, it gives alcohol. It is the primary alcohol. Yes, I am taking example alkyl magnesium halide R minus MgX plus in presence of formaldehyde. this is the formaldehyde. Yes or no? This is the formaldehyde. What happened? See, pi bond is shifted. You are getting partial positive charge. So the negative charge attacks over here. What is the product? See, what is the intermediate? See, H, see, C, here, O, MgX, yes, X, H and H. With H2O, what happened? Breaking. So to form a R, CH2OH, CH2OH. Yes, this is the product. I am writing RMgX alkyl magnesium halide in presence of epoxide CH2, CH2O. So it forms O minus, here carbon positive charge. So negative charge attracted by positive charge. It forms CH2, CH2, OMgX and R. And again it is treated with H2O to form a what? CH2, CH2OH. Yes, this is the product. Next, this is for primary alcohol. Primary alcohol. I will look for secondary alcohol. Secondary alcohol. See, secondary alcohol. RMgX. Alkyl magnesium halide. See, alkyl magnesium halide R minus G plus, which it is treated with aldehyde. CR, C double bond O, H. It is a aldehyde. What happened? Pi bond is shifted. Positive charge here attacks the negative charge. C R, C R, here O M G X with H2O. It form R CH2 R2 CHOH. It is a secondary alcohol. It is a secondary alcohol. Yes. Next, alkyl magnesium halide with HC double bond OR. See, it forms pi bond is shifted, positive charge. It forms HCr OR C OMgX. Again, it is treated with H2O. It forms C double bond O or in presence of alkyl magnesium halide with water. It gives HCrROH. I am taking tertiary alcohol. See, tertiary alcohol. Tertiary alcohol. See, alkyl magnesium halide. Alkyl magnesium halide with a ketone or C double bond O R. See, it forms positive charge, attacks here. See, what happened? R O M G X and R. It is treated with H2O. It form R and OH. It is a tertiary alcohol. Tertiary alcohol. Again, I am taking one example. See, MgBr. Yes, with CH3 C double bond H. What is the product? What is the product? See, here positive charge, pi bond shifted. So here getting what? MgBr means C CH CH3OH. Yes, or we can use cyclohexane with aldehyde plus methyl magnesium bromide. Both are giving the same product. Both are giving the same product. Yes. So look for see if I'm taking one reaction. This is the question. Benzene with the bromination. What happened in presence of ferric bromide? It gives bromobenzene. Yes. Again, it is treated with magnesium in tetrahydrofuran. What happened? It gives MgBr. Yes. And this benzene is treated with acyl chloride in presence of anhydrous AlCl3. It gives what? This is the product. When it is treated with phenyl magnesium bromide. See, it is a phenyl magnesium bromide in presence of H2O. What is the product? See, very simple. It is a previous question. See, this is the product. I will look for next question. With methyl magnesium bromide. What is the product? This is the product. Again, one more example. See, in presence of ethyl magnesium bromide H2O. What is the product? Product. Yes. I will look for chemical properties. Chemical properties. The first one is acidic nature. Acidic nature. See, alcohol in presence of metals to form a what? Alkoxide ion. Alkoxide ion. Metal oxide. Metal alkoxide to produce H plus. Yes or no? For example, I am taking alcohol with sodium hydroxide. Sodium to form a sodium alkoxide. Yes, to produce H2. To produce H2. Yes, H2 is a weak acid. Again, alcohol, sodium hydroxide. Sodium hydroxide. It forms what? RO in a plus H2O. H2O is a weak acid. Yes, alcohol is a strong acid. Next, if acidic strength is directly proportional to negative inductive effect and inversely proportional to positive inductive effect. Yes. If alcohols are acidic nature, the reaction with metals to form a metal oxides to release the hydrogen gas. Alcohols behaves like acid when OH bond is cleavage, OH bond is breakage. See, what is the reactivity of alcohol? Alcohol. Reactivity of alcohol is, see, methanol. Primary, secondary, and tertiary. Ethanol is more reactive than primary, secondary, tertiary alcohol. Okay, so one more important. Generally, C2H5OH, which is sodium hydroxide, no reaction. No reaction. So sodium alkoxide with water to form a alcohol and sodium hydroxide. Sodium alkoxide with water it decomposed to form a alcohol and sodium hydroxide. But ethanol does not react with sodium hydroxide. See, I am writing one question. So first one, it is the second one. It is a acidic strength. So it is a F, it is a CH3, means it is a positive inductive effect, it is negative inductive effect. So second is greater than first. Yes, in acidity, primary is greater than secondary is greater than tertiary. In hydrogen halide, they are tertiary, secondary, and primary. So in OH cleavage bond, primary is greater than, secondary is greater than tertiary. In RO bond cleavage, tertiary is greater than secondary and primary. Yes. One more important question. Sodium readily react with the see what CH3OH is there. Yes, and E2OH ethanol is there, and CH3OH it is a secondary, and CH3OH which is more readily react with sodium. Very simple, methanol. Yes, methanol is more reactive because that is a primary is greater than, secondary is greater than tertiary. Yes. Yes. Esterification in acidic medium. Next reaction is alcohol with carboxylic acid in acidic medium to give ester. Alcohol with carboxylic acid in acidic medium to give ester. Yes, see, carboxylic acid again it is treated with acyl chloride or COCl. Yes, it is a acylo cleavage mechanism. It undergoes acyl cleavage mechanism to form a ester. It is also forming ester and HCl. Again, alcohol with acetic anhydride, CrC double bond O C double bond O R dash. It forms as R C double bond O R ester, and carboxylic acid. It forms R C double bond OH. It gives carboxylic acid. See, this is a esterification. This is a esterification. See, have a look for. Very easy to write the product. See, what is the trick? Very simple. Carboxylic acid RCOH plus alcohol CH, like that. See, remove the water, H2O, add the product RC double bond O R. This is a way to write the esterification product. What next? Next is the dehydration of alkene. Next is the dehydration of alkene. See, dehydration of alkene. See, next is the dehydration of alkene. See, ethanol. What is the dehydrating agent? Concentrated sulfuric acid. Yes, C2H5OH in presence of concentrated sulfuric acid at 170 degrees Celsius. It gives alkene. CH2 double bond CH2. Yes, I am taking CH3, CH2, CHOH, CH3 in presence of con H2SO4. Heating, it gives CH3, CH double bond CH3, and CH3, CH2, CH double bond CH2. It gives two products. Yes, which is major? This is the major, this is the minor. So due to it is, which is a Sage-Job product? This is a Sage-Job product. Who follows Sage-Job rule? Sage-Job rule. Yes. Again, ethanol C2H5OH in presence of alumina Al2O3 at 350 degrees Celsius, it gives alkene. Alumina at 350 degrees Celsius, it gives alkene. See, right? C2H5OH, C2H5OH in presence of H2SO4 at 140 degrees Celsius, it gives ether, diethyl ether. It gives ethyl ether, C2H5O, C2H5O. What is at 140 degrees Celsius? Excess ethanol. Excess ethanol is taken at 140 degrees Celsius, it gives diethyl ether. See, again, ethanol C2H5OH, C2H5OH in presence of Al2O3, alumina at 200 degrees Celsius, 200 degrees Celsius, it gives ether C2H5O and C2H5O, C2H5O, C2H5. Yes, yes. 170 degrees Celsius at 140 degrees Celsius. At 170 degrees Celsius, temperature rise, it gives alkene. At 140 degrees Celsius, it gives ether. Yes, see. I will look for next. Low-cost reagent. What is low-cost reagent? Mixture of HCl and anhydrous zinc chloride is a low-cost reagent. It is an identification for primary, secondary, tertiary alcohol. So alcohol ROH in presence of concentrated HCl and anhydrous zinc chloride. See, anhydrous zinc chloride, it gives alkyl chloride. It gives alkyl chloride. See, primary alcohol. See, primary alcohol in presence of Lucas reagent. So no reaction at room temperature. No reaction at room temperature. See, secondary alcohol in presence of Lucas reagent, it gives white turbidity after 5 to 10 minutes. See, turbidity is formed after 5 to 10 minutes. Yes, in tertiary alcohol with Lucas reagent, white turbidity is formed immediately or instantaneously. See, white turbidity instantaneously formed. Yes. See, one more important. See, allyl benzyl alcohols react with rapidly as tertiary alcohol to form a soluble chlorides with Lucas reagent. Allyl benzyl alcohol react with rapidly as tertiary alcohol to form a soluble chloride with Lucas reagent. See, for example, tertiary alcohol immediately formed. So, for example, one more special case is there. For example, it is a not alcohol, it is a primary alcohol. Yes, primary alcohol. Yes, primary alcohol in presence of what happened? It forms carbocation. Resonance is possible. Yes, resonance is possible. Resonance is possible is stabilized by resonance. So it gives immediately turbidity. Yes. Now again, look at for this example. It is alcohol. Also resonance possible. It is also giving immediately white turbidity. Immediately give the white turbidity. See, have a look for question. So which is gives more readily tertiary. It is a tertiary, it is secondary, it is primary. It is primary alcohol, it is secondary alcohol, tertiary alcohol. So identify time for turbidity. So identify time for turbidity. So which is time taken high? Time high is what? First one is greater than second one and third one. Yes. Next is reaction with phosphorus trihalate, pentahalate, thionyl halate, red phosphorus. Yes. So all are alcohol with the reagent, it gives alkyl halate. Yes. See. Next, oxidation of alcohol used to distinguish primary, secondary, tertiary alcohol. See, primary alcohol. Oxidation, it gives aldehyde or CHO. Again oxidation, it gives carboxylic acid. Yes. Next, secondary alcohol. See, secondary alcohol oxidation, secondary alcohol oxidation, it gives ketone or C double bond O. And tertiary alcohol oxidation, it gives what? It do not oxidize, oxidizes. Next, let's take example. If taking of oxidizing agent, it is a H2Cr2O4 oxidizing agent. It is a chromic acid. Chromic acid, it forms what? Ketone. Yes. Next is a dehydrogenation. What is the reagent? Copper at 300 degrees Celsius. This reaction is a test for the identification of the alcohols, primary, secondary, tertiary. Yes, I am taking primary alcohol, CH3CH2OH, copper at 300 degrees Celsius, it gives CH3CHO, total is H2. Yes, again CH3OH with copper at 573 Kelvin temperature, it gives ketone. CH3 which OH at copper at 573 Kelvin, it gives alkene. Yes, it is a primary, it is secondary, it is tertiary. Yes, see. Next is a phenol rearrangement. Phenol rearrangement. See, I am writing R C Yes, it is a phenol in presence of H2SO4. It gives pinacolone. See, colone. I am writing mechanism for this. See, H R OH are in presence of H plus. Yes, what happened? Water is eliminated. OH2 plus. Yes, it is eliminated to form a C. Carbocation is formed, and R. Yes, what happened? Migration. Alkyl group is migration of alkyl group. What happened? See, R with the carbo. Yes. So here OH. So it is these two electrons are shifted here. They are getting positive charge. Yes, I am writing C. R C double bond OH R. Again lose H plus. it gives, or C double bond O, or it is a pinacolone. This is the mechanism. This is the mechanism. See, have a look for one question. H, OH. Yes, in presence of H plus. Presence of H plus. What happened? See. OH, OH2 plus. Water is eliminated. It forms carbocation. Cation is formed. Yes. Here what happened? Ring expansion is happened. Ring expansion. Yes. The breaking of bond with this position and this to form a ring expansion to form a getting positive charge. This is shifted to forming product. Yes. This is complete revision of alcohols. Yes, I hope like this video. Don't forget to share your friends. Don't forget to give like. If you find this content is valuable, make sure to subscribe to our channel and hit the bell icon to stay updated with the latest videos and notifications. Thanks for watching.